In lesson 44, we discuss the chain rule and we learn about a couple different definitions of the derivative rather than the limit as h approaches 0 of f of x plus h minus f of x all over h. So there's a couple different ways to look at that, and a couple of those ways are in this lesson. But we will start off with the chain rule. And as you can see here in this sentence right under the chain rule, it says the chain rule is simply recognizing some patterns that occur when using u substitution. So we've been using u substitution for a bit now when we have some composite functions, a function within a function. And when we do that, and maybe you've seen that already as you've been using u substitution, that there's some patterns that occur and you actually don't need to write out all the different parts. So you have the two different notations here. You have Leibniz notation. It says dy over dx equals dy over du. So the derivative of y in terms of u times du dx. And then Newton's notation might just be an easier way to think of it. But you have if h of x equals a composite function, so f of g of x, then to find the derivative, it's simply the derivative of f with the g function still in there times the derivative of g of x. And it's called the chain rule because they just kind of link together. You take the derivative of the outermost times the derivative of what was inside that function. And in fact, it doesn't just have to be two functions. You can have several functions within each other and just keep applying the chain rule. So let's take a look at this first one. It says, let dy equals u squared plus 4u, and u equals 5x cubed. Find dy dx. Well, this is in Leibniz notation, so let's go ahead and do that. So if we want to find dy dx, let's come and look up here. Dy dx is simply going to be equal to dy du. So we want to find the derivative of this. So dy du is 2u plus 4 times du dx. So times du dx, which is 15x squared. Now we're asking for dy dx, which has nothing to do with u in here. There's no u's in dy dx, so we go ahead and substitute things back in. So dy dx is equal to 2 times u, but u is 5x squared. Sorry, 5x cubed, plus 4 times 15x squared. And then you simplify that, and you have your answer. So I think what I'll do here is factor a 2 out of these two terms, and so we end up getting, so that 2 will be multiplied by the 15x squared, so we have 30x squared, which is going to be times 5x cubed plus 2. And there's our answer. Another variation would just be to distribute the 30x squared into both those terms. All right, on to the next one. dy du. Well, it's going to be dy dv, so we're using a v here. So dy dv is going to be 2, derivative of natural log of v is just 1 over v, so 2 over v, and then times dv du, and so this is going to be times 2u, but we want dy du, so we don't want a v involved in our answer, so dy du is going to be, so we can multiply This is over 1, so we have 4u. But what is v equal to? Well, v was equal to u squared, so we can put u squared down here instead of v, and then we can actually simplify some more, and we get 4 over u. So 4 over u. And then our last one, this one doesn't have it separated into two parts. So it doesn't have it separated like that. And in fact, this is how we will normally see functions. And so this, I want to make sure we get, and this I believe is the easier way to do this. So we want to find dy dx. And as we look at this function, this is where we really can see the chain rule idea. This is primarily a sine function. So it's the sine of, a lot of times we like to write this not in a square root form, but it would be x to the negative 1/2, because that square root's in the denominator. It's a square root, so it's x to the 1/2, and we can bring it to the numerator by making it negative. And so we want to find the derivative of this function right here. And so all we need to do is we take the derivative of the main function, which is sine. So we think, what's the derivative of sine? Well, the derivative of sine is cosine. So it's cosine of, still of, the x to the negative 1/2. So cosine of that. So cosine of x to the negative 1/2. And then you multiply it by the derivative of what's in the sine. So the derivative of this highlighted part. So what is the derivative of x to the negative 1/2? Well, the negative 1/2 comes out. X, subtract 1 from that, and you get negative 3/2. So that's the derivative. We can put that in a little bit better form by simplifying, put it in a better form. There are a few different ways to write this. So this is going to be cosine. Actually, I don't want to start with cosine. We'll go ahead and start with this. So this is negative 1/2. This can go to the denominator because it's a negative. So this is the square root of x cubed. And then the cosine, we can just say cosine of 1 over square root of x. This form is okay, so we could leave it like that. Probably put the negative 1/2 out front. So either one of these forms is okay. So that's the first part of lesson 44. That is the chain rule. I actually want to squeeze one more in here just for practice. I'll make another video for part 2. So I'm just going to make up another example. Let's say y equals the square root of the sine of x to the 4th. So this actually is 3 functions, kind of. So let's rewrite this. Let's say, remember that this is sine of x to the 4th to the 1/2 power. Now we have to be careful. We can't do anything with this 1/2 and the 4. They can't combine. So if I want to find the derivative, so I'm just going to put y prime. First, I think, what's my main function? Well, the main function is the square root function, or the 1/2 power. That's the outermost function. So what's the derivative of something to the 1/2 power? Well, we bring the 1/2 out front. We use the power rule. The 1/2 comes out front, times the sine of x to the 4th. And we subtract 1 from that, so to the negative 1/2. So we took care of the square root part, to the 1/2 power. Then we multiply that by the next part. So the next part is sine of something. So what's the derivative of sine? Well, the derivative of sine is cosine. So it's cosine of x to the fourth. And then finally, we look at the x to the fourth. We take the derivative of x to the fourth. That's the innermost function. So what's the derivative of x to the fourth? Well, it is 4x cubed. And as mentioned before, we should simplify. So y prime equals, let's see here, 2 and 4 reduced to 2. So let's go ahead and write 2x cubed times cosine of x to the fourth times, actually we can put it back in this, well, let's just leave it like that, times this sine of x to the fourth to the negative 1/2 power. So that's the chain rule. You just take the derivative of the main function, multiply it by the function within that, and if there's more, you just keep putting on those extra links, taking the derivative of what's inside the other functions. All right, and that is the chain rule.